Dr. Elio D'Appolonia was known for undertaking challenging projects and finding innovative solutions that resulted in significant cost savings. Dapp was born April 8, 1918, in Coleman, Alberta, Canada. Dapp received his BS and MS degrees in civil engineering from the University of Alberta and his PhD in structural engineering from the University of Illinois. In 1942, Dapp married his longtime sweetheart Violet, known to her friends as Tina. The couple came to Pittsburgh in 1948, and Dapp took on an assistant professorship at Carnegie Institute of Technology, where he built a strong soil mechanics and foundation engineering program. In the early 1950s, Dapp expanded his career and began providing geotechnical consulting services in addition to his academic responsibilities. Later, he formed D'Appolonia Associates and began working as a full-time consultant. Dapp contributed greatly to the profession through his research projects. In 1946, he and his mentor, Professor R.M. Hardy, published a paper on their permafrost research. In 1948, they received the Kiefer Medal from the Engineering Institute of Canada for the best paper in civil engineering. Dapp's doctoral studies, under Dr. Nathan Newmark, focused Dapp's interest in an innovative work in numerical methods. Dapp's contribution was significant. He improved upon the lattice analogy numerical method, which has evolved into today's finite element method. Dapp was known for undertaking challenging projects that other companies said could not be done the way Dapp had proposed. Yet Dapp succeeded and saved clients millions of dollars. Some prime examples of his work include the Lewiston-Queenstown Bridge, the Bethlehem Steel Plant, now ArcelorMittal, the Olympic Velodrome in Montreal, Canada, and the Weirton Steel Mill expansion. The Lewiston-Queenstown Bridge, a bridge that crosses the Niagara River Gorge just south of the Niagara Escarpment, has an arch 1,000 feet in length. Dapp designed the temporary falsework foundations for support of the arch during its erection over the Niagara River. The side slopes of the gorge consist of rock talus that is continually creeping downslope due to river erosion. The foundations were carefully monitored and jacked to maintain support for the arch. The abutments were also carefully monitored, as the erection of the arch placed large tensile forces in the rock until the arch was closed. The bridge was completed in November 1962. In the early 1960s, Bethlehem Steel began building a fully integrated steel mill in Burns Harbor, Indiana, at the southern tip of Lake Michigan. The design engineer proposed to found the steel mill on piles. Dapp convinced Bethlehem that, with the exception of a few heavy structures, the mill could be supported on shallow spread footings. This approach saved Bethlehem Steel millions of dollars. The velodrome for the 1976 Montreal Olympics was designed as a tensioned dome anchored at 3 massive concrete abutments. The dome was to be supported by temporary scaffolding during construction. Once the dome was completed, it would be jacked into place by tensioning rock anchors installed through the concrete abutments. The jacking program required by the dome design engineer was not possible to implement in time for the start of the Olympics. Dapp and his staff performed a field investigation and developed a finite element model of the bedrock beneath the velodrome. Dapp proposed an alternate arrangement of rock anchors and a much more rapid stressing of the anchors. With Dapp's approach, the velodrome was completed a month prior to the Olympics opening ceremonies. In the mid-1960s, Weirton Steel proposed a significant plant expansion. Site exploration revealed that the expansion would involve cutting into a large colluvial slope. The colluvial soil developed on the hillside by weathering of the underlying rock. Slope creep results in low-strength, slickened side zones in and at the base of the colluvium. The required cut at the toe of the slope varied in depth from 30 to 60 feet. An anchored steel sheet pile wall was designed to permit excavation and drainage galleries constructed in the slope to provide long-term stability. Dapp is very active in his professional life. He was a founding member of Terra Insurance. He was also chairman of the executive committee of ASCE's Soil Mechanics and Foundations Division. The SMFD recognized Dapp's contributions to the profession with their prestigious Terzaghi Lectureship. The title of his Terzaghi Lecture was Monitored Decisions. It was through the monitored decisions approach that Dapp was able to propose innovative solutions to numerous engineering problems. Over the years, Dapp's accomplishments have been recognized by many organizations and institutions, including his election to the National Academy of Engineering, the William H. Metcalf Award for Outstanding Engineering Achievement from the Engineers Society of Western Pennsylvania, an honorary degree of Doctor of Engineering from Carnegie Mellon University, and selected as an honorary member to the American Society of Civil Engineers, just to name a few. We are pleased to honor Dr. Elio D'Appolonia today for his pioneering work and wonderful contributions to the geotechnical engineering profession.